Good afternoon. Today we will be discussing the topic Geographical Information System. So, Geographical Information System, it is an integrated tool that is capable of mapping, analyzing and manipulating and also storing the geographical data in order to provide solutions to real world problems and also help in planning for various services for the future, for preparing topographical map, for socio-economic and environment modeling, and also for taxation purposes. We use this geographical information system. For the business, for the development of business and other activities, we rely upon GIS. Then for logistics, for transferring goods and services from one point to another, for that also we use GIS. Then for certain disasters, during the times of disasters, for disaster management, we rely on geographical information systems. And also for sensing the changes in the environment, what is the effect by which certain flora and fauna and the environment is affected by various changes in the environment, in the atmosphere. So all that we can model and we can understand, and also for education purposes we rely on GIS. So GIS is a very important tool which can do all this. It can map, it can analyze, it can manipulate, and also it can store the data of a particular area or a country as a whole, and this data can be used for solving problems in all these areas which I have mentioned before. So, and that can be used for the planning for future, and thus it has got wide application. So that is about geographical information system, just an introduction about GIS. Now we will be discussing the various objectives of GIS. The first is to maximize the efficiency of planning and decision making, then to integrate the information from multiple sources, and to facilitate complex querying and analysis, and to eliminate redundant data, and to minimize duplication. So some data will be having multiple data of the same thing, or we will be having unnecessary unwanted data, so that can be eliminated. So these are the objectives of GIS. Now this is a flowchart showing the interrelationship of various components of geographical information system. So first we will get familiarized with the various components of GIS. So GIS mainly it has a hardware part. So this hardware means it consists of the equipments and the support devices that are required to capture, store, process, and also to visualize the geographical information. So basically it includes the computer, the hard disk, the computer with the hard disk, then scanners, printer, plotter, all these hardware components. That is the major or important part of this GIS. Then second one is the software. So it is normally termed as the heart of the GIS system. The GIS software, it should have basic ability to input the data, to store the data, to transform the data, then to analyze and finally it should be able to provide the required output. So these are the main another integral part of another integral component of GIS. So that is the software. So different softwares are used, and these softwares can be broadly divided into proprietary type of softwares and open source softwares. So these proprietary software means examples are ArcGIS, then Geomedia, MicroStation, etc. And open source includes Quantum, Grass, that is a very frequently used or commonly used type of GIS software, which is open source like Grass, then Map Window GIS, etc. So these are the different type of softwares used. Now the next important component is the data. So the data that is which is captured or collected from various sources, that may be by aerial photography or by with the use of satellite imagery will be taken. Field observations like triangulation survey will be conducted and data will be obtained. So all these are the data, and that has to be processed for analysis and presentation. Then methods. So we'll be discussing the methods in detail in the coming classes or in the coming session. So basically methods means the procedure or the way by which data has been entered in the system, how it is retrieved, how it is processed, and how it is presented. So all these, the procedure, that is what is there in the component called methods. Then the final one is the people. So people means the user or the individual programmers or the people who are managing the database, that is a database manager or the GIS researcher. So those people who are involved in the GIS work, or they are the users or the stakeholders, that is people who are using these GIS services or tools. So they are also the people. So they are also there in the component in that part called the people. So we all basically use this data for different we use this data, the data from data which is available in the web for education purpose. So and we rely on these methods for our online classes. So we are also the stakeholders of this GIS system or geographical information system. So that has been discussed in the slides, and after this is again a representation of the GIS components. Then the application of GIS, that is also very clear from the slides. So the major applications: topographical mapping, then socio-economic and environment modeling, education, then tax mapping, then business, logistics, then emergency evacuation during times of disaster, then environment, that means how the anthropogenic effects, like due to human activities, how this environment is affected. So that can be and associated phenomena can be modeled, and predictions can be made using this software. So that is GIS applications. Now coming to the GIS operations, geographical information system, the various operations can be, or it consists of a database which is coupled with a graphics output. There are mainly three major types of operations. The first one is the access methods. So here the user will want to access the data elements with certain properties. So suppose I am a user, I want to access the data which is available in the GIS, and I want to obtain the coordinates or the latitude, longitude and elevation of my location. So in that case I have to if I am obtaining the such data, so I want that data in with certain properties. Sometimes the map, my location will be available in the map, but I need it as latitude, longitude. So in that case, this is the access method. Here the user, that is myself, I want to access that data element in which form? As latitude and longitude. So that is the property of the data which I want. Now analytical operation. So analytical operation is another major type of GIS operation where it allows the user to combine the data to produce a new data. So suppose I am obtaining the coordinates of one point that is near to the front entrance of college, and using that data or using that as the reference data, I am as the benchmark. Okay, I am doing survey using total station for the whole college campus, and then I am producing a map, and this map I can share with people who other users also. So I am actually using the or combining I'm using the data which was produced by the GIS operation. I'm using that as the base, and then I am combining my own data, and finally I'm producing a new data. Okay, so that is a map of the campus, college campus. So that is the kind of analytical operation. Then rendering operations show the data as some sort of map with additional information displayed. So here finally I am rendering this data and I'm making a 3D model of the, and I want to construct a new block in our college. So something new I am adding to that map, and I am developing a 3D map. So this is the part called rendering. So these are the three major operations in GIS. So access methods are there, analytical operation, and rendering is there. So finally initially there was a actual topography or the real world, and this has been converted to GIS world. So in this we have a topographical base, different layers are there. So and all these layers will be having data related to a particular area only, and finally we will be combining all these and we'll be getting a composite overlay. So all these first one will be like zones, second one will be the floodplains, then third one wetlands only, then land cover only, then soil type only, and all these will be combined and a final composite overlay will be produced, and that will be rendered, and finally it can be used for future planning and other works. Like this can serve as a resource to help in planning for future. So these informations from different sources, multiple sources, are integrated, and finally we are creating data which is having maximum efficiency in the planning work and decision making work that can be used for planning and decision making, and we are also eliminating duplication of data, and unimportant or unwanted data are eliminated in this process. So that is the GIS operations. Now we are moving on to the next topic, that is map projections. Okay, so here Map projection means it is actually a method, it's a mathematical procedure or an expression using which the three-dimensional surface of the earth can be represented in a 2D plane. So the process of projection results in distortion of one or more map properties like shape, size, area or direction, because we are actually converting a 3D subsurface and we are representing it on a 2D. So always there will be some sort of a distortion in the form of shape, size, area or direction. So in order to minimize this distortion, we have to adopt a combination of projection systems. Okay, so a single projection system will never give you the correct representation of all the map properties. So we have to adopt different projection systems, and a combination will help you to yield a map or a particular a projection with minimum distortion for a particular region or for a particular area. So the different methods, I told you there are a number of methods, so we are actually studying only these 4 map projection methods. So method of construction, development surface, projection properties, position of light source. So now we will discuss each of these in detail. The first one, that is method of construction. So it can be broadly categorized into perspective projections and non-perspective projections. So perspective projections means these are made with the help of a shadow cast from an illuminated globe onto a developable surface. So here there is a that is this type of perspective projection that is made with the help of a shadow which is cast from an illuminated globe onto a developable surface. So if you have a globe that is lit and suppose you are holding a torch, and so the shadow will be cast, and that is that can be developed, that can be projected, and that can be converted to a map. Whereas in non-perspective projection, this projections are not made with the help of a shadow cast from an illuminated globe onto a developable surface. So the non-perspective projections, here a developable surface is only assumed to be covering the globe, and the construction of projections is done using mathematical calculation. So here it is basically it is made of in the earlier thing will be like graphics, like we do in graphics, how we draw the perspective projection, like that we will be visualizing and we will be drawing. Whereas in non-perspective projection, it is purely based on mathematical calculations, will be doing the projection. Okay, now the second method of map projection, the second type or second method which we discussed earlier was development surface used. So here the projection transforms the coordinates of the earth onto a surface that can be flattened to a plane without any distortion. So such a surface is what is called as a developable surface. So the type of projections which we use here are, first one is called as a cylindrical projection. So in cylindrical projection, it can be visualized as a cylinder which is wrapped around the globe. So here you can see 3 different aspects of cylindrical projection. The first one is normal. So normal means when the cylinder has the line of tangency to the equator. So here you can see this particular cylindrical projection means a cylinder is wrapped around a globe. So here we have the earth. So the earth is at the center, and around this particular earth there is a cylinder. So this particular cylinder is placed such that the line of tangency is to the equator. So here the equator of the earth, okay, you can see the equator, this is the equator. So the equator of the earth is actually tangential to the cylinder, which is actually wrapped around the globe. So in that way we'll be visualizing and we'll be drawing the projection. So here the longitude, that is the north-south line, okay, you can see, and also the latitude, that is the equator here. So they are appearing, they are once you project you'll be getting it as a straight line. In the second figure you can see that just the reverse, just the opposite of the first figure, okay. So that is the transverse aspect of cylindrical projection. Here the cylinder has a line of tangency to the meridian. Meridian means what? The north-south line. So here the north-south line is tangential to the cylinder. Then third one, that is oblique. So here when the cylinder has line of tangency to another point on the globe, so other than this equator and meridian, any other line if you consider on the surface of the globe or the earth, so that line is actually tangential to the cylinder. So if you place the cylinder wrapping the earth or the globe in such a way that any line other than the equator and the meridian, so that is actually tangential. So in that way if you get the projection, that is called as oblique projection. So we are actually discussing about the different types of development surface used. In that, first we have discussed about cylindrical projection. Now the second type in the development surface used is conic projection. So here it can be visualized as a cone which is placed on the globe, such that the cone is tangent to the globe at some parallel line. So you will get the projection in this method. You just need to understand. So this is how it looks. This is one type of, again, conic projection can also be divided into different types, of which one particular type is shown here. But you don't need to discuss that in depth regarding each of these types of conic projection and cylindrical projection. Just you need to know that depending on the type of developable surface, we have different types like cylindrical, conic. Then the third one is the azimuthal or zenithal projection. So here it can be visualized as a flat sheet of paper is tangential to any point on the globe. So here we have, this is the North Pole. So you can see the pole, North Pole and South Pole. How? Because we are looking from the top, that is like a flat sheet of paper which is tangential, which is touching the globe at the North Pole. So, and if the projections are made on that flat paper, this is how it will look. So this is how azimuthal or zenithal projection is done. So these are the three different types of projections which come under the heading, development surface used. So we are studying map projections. So map projection methods, broadly it can be categorized. There are so many types, but broadly it can be categorized into four. First one is method of construction. Second one is development surface. So development surface used again can be categorized into three. First one is cylindrical, then conical, that is the second one, and azimuthal or zenithal is the third one. Again, the third type of map projection is projection properties. So projection properties we'll be discussing in the next slide. Okay, this is projection properties. So here you can see, according to the properties of map projection, according to the properties of the adopted, okay, there are different map projections. First type is equal area projection or homolographic projection. the areas of different parts of the earth are correctly represented in, but to a certain extent is correctly represented. What? The area. So if the areas are correctly represented, we call it as equal area, or it is also called as homolographic projection. So what is the property there? The property is that the area is correctly represented. In the second type, the true shape or orthomorphic. So here the shape is correctly represented. So in that case we call it as true shape projection or orthomorphic. Okay. So orthomorphic or true shape projection, what does it mean? The shape, what is the property being fulfilled there? The shape is correctly represented. Then third is true scale or equidistant projection. Here the projection maintains correct scale, so it is called as true scale. So this is very easy to remember. So based on the property, we have different names. If it is if the area is correctly represented, that is called as equal area projection or homolographic projection. If the shape of different parts of the earth, that is correct, shapes are correctly represented, then we call it as true shape projection or orthomorphic projection. If the correct scale is maintained, we call it as true scale or equidistant projection. Okay. So next is the fourth type, that is based on the position of light source. So placing the light source which is illuminating the globe at different positions, that can result in the development of different projections. So these are mnemonic projection, when the source of light is placed at the center of the globe. Then stereographic projection, the source of light is placed at the periphery of the globe, that is, it is diametrically opposite to the point at which the developable surface touches the globe. Okay. Then orthographic projection, that is when the source of light is placed at infinity, so at infinity from the globe, opposite to the point at which the developable surface touches the globe. So it is at infinity means what? The lines will be parallel, or it will be parallel to each other, it will be perpendicular to the plane of projection. So that is why the name orthographic. If the lines source of light is at infinity, means we know the lines, the rays will be parallel to each other and it will be perpendicular to the projection, the projecting surface. So here you can see the representation of the different projections based on the position of light source. First one is mnemonic, then stereographic and orthographic. So that is first one, the light source is placed at the center of the globe. Second one, so you can see in mnemonic the globe, center point of globe, there from there the light is emitting, so the rays will be like this. In the second type, light source is placed at the periphery of the globe. Okay, that is diametrically opposite to the point at which the developable surface touches the globe. So this is the point where the developable surface is touching the globe. So diametrically opposite that, at this point the light source is kept. Orthographic, the line source is at infinite distance. Now we will be discussing the next topic, that is coordinate systems. So a coordinate system is a reference system that is used for locating the objects in a 2 or 3 dimensional space. So it is just a reference system, and using this reference system we can locate the objects in a 2 or 3 dimensional space. So we have this coordinate system. If you draw in CAD drawings with respect to a particular 0, 0, 0, that is origin, we will be locating the points. So the points will be having x, y, z coordinates. So that is simply you are very well aware of the coordinate system. A geographic coordinate system or global or spherical coordinate system is a reference system that uses three-dimensional spherical surface to determine the locations on the earth. So here we can reference any particular location on the earth by a point with longitude and latitude. So using the latitude, that is the line which runs horizontally around the globe, that is from 90 degree north to 90 degree south. That means what is the latitude? We know, the east west, which connects the east west. So it is also known as parallels. So they are equal. We know latitudes are equidistant from each other. So using this latitude and longitude is perpendicular to this. So they are measured from 180 degree east to 180 degree west. That is north south line. So using this latitude and longitude, we can locate any particular point on the surface of the earth. Next is projected coordinate system. A projected coordinate system is defined as two-dimensional representation of the earth. It is based on a spheroid geographic coordinate system, but though it is spheroid, it uses linear units for coordinates. So it's also called as Cartesian coordinate system. In such a coordinate system, the location of a point on the grid is identified by xy coordinates. So x means the distance from y-axis and y is the distance from x-axis. So that also you know. So here the linear distance, that is x and y, but in the case of geographic coordinate system, it was actually the latitude and the longitude. So that is the basic difference between the geographic coordinate system and projected coordinate system. In projected, it is the x and y distance, whereas in geographic it is the latitude and the longitude. Now we'll be dealing with the data types. So data types can be categorized into two: spatial data and attribute data. So all types of data, objects or elements that are present in geographical space. So as the name itself indicates, spatial data, it is present in the space or the horizon, whereas attribute data means it is the characteristic of geographical features that are quantitative or qualitative in nature. So the satellite images and scanned maps help to obtain the spatial data, that is the elements which are present in the space or horizon. Town planning and management departments, fire department, environmental groups and online media, they help to obtain the attribute data. So that is something which is quantitative or qualitative in nature. Then data type can, this spatial data, it describes the absolute and relative location of a geographic feature, whereas the attribute data describes the characteristics of a geographic feature. So this is the basic difference between the spatial data and attribute data. Spatial data are used to provide the visual representation of a geographic space, and that can be stored as so spatial data can be represented in two ways, that is one either as vector type or a raster. So this data is a combination of location data and a value data in order to render a map. Whereas the attribute data, they are the descriptions. I told you attribute data, it is a characteristics of the geographic feature that are qualitative or quantitative in nature, and it describes the characteristics of a geographical feature. So here you can see attribute data means it consists of the descriptions or classification of the features, and that can again be classified into 4 levels of measurements: nominal, ordinal, interval and ratio. Nominal means it is the lowest level of measurement for distinguishing features qualitatively using the type or class, like the different tree species. Ordinal means they are ranked into hierarchies, but it does not show any magnitude of difference, like city hierarchy, etc. Interval measurement indicates that the distances between the ranks of measured elements, but a starting point is arbitrarily assigned. So there will be a starting point that is roughly taken, like Celsius temperature, etc. It indicates the distance between the ranks of measured elements. Then a ratio measurement means that is the highest level. So the lowest level was nominal level, then comes ordinal, then interval, and the last one is ratio. So it includes an absolute starting point. Data of this category include the property, value, and distance. So attribute data is the detailed data which is used in combination with the spatial data in order to create a GIS. So here we have discussed that this spatial data can be categorized into a vector type and raster type. So vector data. So vector data means it can be these spatial data can be represented either as a point, line, polygon, or a combination of these. So vector data model that is also called as features. So it can be divided into two classes. One, simple features. So simple means easy to create, store, and that can be rendered on screen very quickly, but it lacks connectivity. So only individual data will be there. There is no connectivity or relationship. So they are not efficient for modeling a phenomena. So we prefer topological features. So a topology means what? It is a mathematical procedure that describes how the features are spatially related, and it ensures data quality of the spatial relationships. Topological relationships including the following includes the following three basic elements. One is connectivity, that is there is information about linkages among the spatial objects. Then there is contiguity, that is information about the neighboring spatial object. And containment. Containment means information about inclusion of one spatial object within the another spatial object. So connectivity means here you can see it's an arc node topology. So it defines connectivity. Arcs are connected to each other if they share a common node. This is the basis for many network tracing and pathfinding operations. Arcs represent linear features and the borders of the area features. So every arc has a from node. So here you can see this from node, and at the end there will be a to node. So from node is the first vertex, okay, in the case of that arc, and the to node, that is the last vertex. So these two nodes, they define the direction of the arc. Also you can see the arrow which represents the direction of the arc. So here from this red thing to this to node, so that is the connectivity. There is connectivity being showed between the different data. So these two define the direction of the arc, and the nodes indicate the endpoints and intersections. They can be used to represent point features which connect segments of a linear feature. The next is contiguity. So contiguity means a polygon topology, it will define a contiguity. So we have already mentioned that a point, line, polygon, or a combination of these can represent any geographical feature, then that is called as the vector data. So contiguity here means here it's a polygon. Okay, so this polygon is said to be contiguous if they share a common arc. It allows the vector data model to determine the adjacency. Adjacency means one nearby. Okay, but you can very well understand from these two graphs. See here you can see arc 1. Arc 1 means what? This line, this straight line is the arc 1. So on either sides of this arc you can see A and B. So A and B regions share a common arc, that is 1. So it allows the vector data model to determine how they are adjacent, which all topologies are adjacent to each other. So that can be identified here. Similarly, 2 again, this is region 1 and this is C. So 2 is the arc, this straight line, 2 straight line. So that line, that is the border or the side or that part of the side of the rectangle, that is 2. So it actually it acts as a common line or boundary between the regions A and C. Similarly, that 3 arc 3, that is that line or that arc 3 is actually it is acting as a common arc for regions C and B. Okay, B is that whole area. Okay, similarly 5 arc 4 is acting as a common arc for area B and C. Similarly, arc arc 5 for D and C, and arc 6 for B and D. So that is what is represented in the table which is provided to the provided in this slide. So that is meant by contiguity. How a polygon topology defines contiguity. That is what is explained in this slide. Next is containment. Geographic features cover distinguishable area on the surface of the earth. An area is represented by one or more boundaries defining a polygon. The polygons can be simple or they can be complex with a hole or island in the middle. So here the earlier figure there was a rectangle and inside there was a something, okay, that was an arc. Now here, even inside that particular curved shape, there is a lake or something that is represented by E. Okay, so here in this table it is shown that the polygon B, the arc list, that means the polygon B is actually having boundaries 1, 4, 6 and 3. Okay, 1, 4, 6. So you look at the first figure. So here the B is the area which is enclosed by the arcs 1, 4, 6 and 3. Similarly, C is the area which is that is containment. Containment means this particular area C is covered by arcs 2, 4, 5 and 3. Similarly, D is actually contained by arcs 5, 6, 7. Yeah, only 5, 6 and 7. And E is contained by 7 only. Okay, so the E is that area which is surrounded by arc number 7. So this is called as containment. Okay, the polygons can be simple or complex. So just an example is shown in the slide. Now we'll be studying. So with that we completed the vector model. So vector model, if I'm just revising about the vector data. First we have told that first we have discussed that vector data means it represents any geographical feature using a point, using through point, line, polygon or a combination of these. So we have also discussed about how it can be, this particular feature can be divided broadly into two. It can be broadly divided into two classes, that is simple and topographical. And topographical relationships can have connectivity, contiguity and containment. And what is the definition of connectivity, contiguity and containment? That is what we have explained through the previous slide. So next we are moving on to the next topic, that is a raster data model. So in a simple raster data structure, the geographical entities are stored in a matrix of rectangular cells. A code is given to each cell and this code informs the users which entity is present in which cell. The simplest way of encoding a raster data into computers can be understood as follows. First one, entity model, pixel values, and third one is file structure. So we'll discuss each of these in detail. So in the first figure, you can see the first figure with green colored cells. Okay, that is an example of an entity model. So it actually represents the whole raster data. Here let us assume that the raster data belongs to an area where the land is surrounded by water. Okay, so here land is shown in green color. So here in the first figure it is an entity model. So entity model, certain cells are marked in or colored in green. So green represents the land, whereas the white cells, so around these green cells there are so many white cells. So all that represents water, okay, or area where land is not there. So area which is full of water. So that is the white cells. So that is the meaning of the white cells. So it's very easy to interpret. Okay. Next is pixel values. So in the second figure you can see all the cells are filled with either zeros or 1. So the 0 means what? Yeah, 0 has to be encoded as water, and the 1 represents land. Okay, so the pixel value of the full image is shown, and that is the cell having a part of the land, or that is given value 1, and the cell where land is not there, that is given the value 0. Now the third figure represents a file structure. This is very similar to the pixel value type of raster data model. Here only difference is that in the first row, okay, you can see there is a 551. So what is that 551? It means that this particular data structure has 5 rows and 5 columns in the image. So below that you can see, if you count, there are 5 rows and 5 columns. So that is represented by 5. And what is this 1? 1 means it is the maximum pixel value. So maximum pixel value is 1. That means, yeah, the maximum land or the area which is filled with land is given or assigned the value 1. And the other areas where there is no land or which is covered with water, that is given the value 0. Okay, so that is similar to pixel value. Only difference is in the first row there is 551. 5 means 5 row, 5 column, and 1 means maximum pixel value is 1. So another representation, another example of this. Here we are combining two raster data sheets and we are getting the output. So here we are just adding, so it's very easy. We are just adding the different overlays, and finally we are getting the output. So 1 plus 10, that is 11, 3 plus 11, that is 14. Similarly, all the cells, the data values are added. So this is another I told you there are different ways by which this raster can be represented. Raster data model can be represented as entity model, pixel value, file structure. This is an example of the pixel value thing, and next you will see another example of the just an example of entity model. So here zone layer, it defines the zones, that is shapes, values and locations, and next is the value layer. So there we have input values which are used for calculating the output, and these two are added together, and finally you are getting the output, that is the result of the statistic which is applied to the value, that is the final output. Okay, so this is again an example of the entity model. So with that, actually we complete the topics which are as per the syllabus. Okay, so the topic geographical information system, that is that is what we were discussing. So all the topics given in the syllabus, under this heading, that is geographical information system, all the topics we have covered. So thank you all of you. Study well, and all the best for the exams.